example, we're given the function 1 over x, and we're interested in computing the antiderivative, capital F of x. So initially, you may think that the antiderivative of 1 over x would be the natural log of x. And that's a good place to start, but we need to analyze the domain, and we'll realize that we run into a problem if we just leave the antiderivative as natural log of x. So let's start by looking at the original function that we were given, which was 1 over x. Let's look at this graphically. So you may remember this is the reciprocal function, and it has a branch here in the first quadrant, but it's an odd function. It also has another branch down here in the third quadrant. So the domain for this function is all numbers except for 0. So that would be written negative infinity to 0, union 0 to infinity. So that was the function we were given. Then if we take a look at what we think the antiderivative is, and initially we're thinking that the antiderivative may be natural log of x, and if we look at the natural log function graphically, remember natural log in any logarithmic function has a vertical asymptote, and you have some restrictions on your domain. So the domain of the natural log function is all values from 0 to infinity. So let's take a look at the two parts of the graphs that correspond. So basically, the original function 1 over x, when we look at this branch that's here in the first quadrant, that corresponds to the antiderivative natural log of x graph here. But what that means essentially is we're missing part of the graph because this other branch on the 1 over x function that was here, that was in the third quadrant, it's missing a piece over here on the antiderivative function. So we can rectify that when we remember to include absolute value around the x, because if we take a look at the natural log of the absolute value of x function, that function is going to have a mirror image graph over here. So then we would end up with a new domain, no longer the domain from 0 to infinity, but now the domain of this function is negative infinity to 0 and 0 to infinity, which matches the domain of the 1 over x function. So essentially, we have matching pieces. So now our branch in the original 1 over x function, which was down here in the third quadrant, it has a corresponding piece on the antiderivative. So that's why we say if the function is 1 over x, then the correct antiderivative, which I'll write as capital F, the antiderivative would be the natural log of the absolute value of x. And it's important to remember to include those absolute value bars around x to be accurate. So now let's use that idea to do an example. So let's take this example here. Find the general antiderivative for the function 5x cubed minus 7x, all divided by x to the fourth power. So remember, we are not going to be undoing the quotient rule. That's going to be virtually impossible. So this is going to be an example where we want to first simplify the function. So I'm going to write this as a division problem, since I'm dividing by x to the fourth, which is a monomial, it just has one term. Then I'm going to go ahead and actually do the division with each of the terms in the numerator. This is sometimes called term by term division. So I'm dividing each term in the numerator by x to the fourth. So 5x cubed divided by x to the fourth will give me 5 over x, and 7x to the first divided by x to the fourth will leave me with 7 over x cubed. Now, if we keep going and we rewrite each of these terms so that they don't contain fractions, then that means I really am going to end up with negative exponents. So this would be 5 over x is 5x to the negative first power minus 7x to the negative third power. So we may want to use this form to compute our antiderivative. But look what happens when we compute the antiderivative of the first term. If we leave our 5 as our coefficient, and then we'll work on the antiderivative of x to the negative first power, if we add 1 to our exponent, then we're going to end up with x to the 0 power. but x to the 0 power is really just equal to 1. So you realize that doesn't work. Undoing the power rule here doesn't work when the exponent is a negative 1. And that's because we really need to think of 5 over x as 5 times 1 over x. And we just discussed the antiderivative of 1 over x. The antiderivative of 1 over x will be the natural log absolute value of x. So when your exponent is a negative 1, like in this case, x to the negative 1 power, it's going to be better to leave the x to the negative 1 as 1 over x. So I'm going to erase and back up. And I'm actually going to end up backing up 2 steps here, and I'm going to change the 5x to the negative 1 power. I'm going to rewrite that instead as 5 times 1 over x. Because that 1 over x is a special case. We have to have the antiderivative of 1 over x memorized as natural log of absolute value of x. Now the 7x to the negative 3rd power is fine. We're going to be able to leave that in its current form. So don't worry about putting that back into a fraction because that's not the special case 1 over x. So now we can compute our antiderivative correctly. So the 5 stays as a coefficient. The antiderivative of 1 over x will be natural log absolute value of x. Then we'll have a minus 7 as our coefficient. Again, now we can use that antiderivative power rule where we add 1 to our exponent. So that will leave me with x to the negative 2 power. Then we'll multiply by the reciprocal of that new exponent, which would be a negative 1 over 2, which is the same as dividing by negative 2. And then because this is a general antiderivative, we do need that constant plus c. So our correct antiderivative will be 5 times the natural log of the absolute value of x plus 7 halves x to the negative 2 power plus a constant. And remember, we can check this by computing the derivative and verifying that we get the original. However, we won't get the original problem here since that was a problem that we simplified. We would end up getting the original problem here once we did our term by term division if you chose to check it.